step into a realm where time echoes through the ages, and the whispers of ancient creatures beckon us to unlock their secrets. Our planet, a grand stage that has witnessed countless lives, has been an orchestra of evolution, each species adding its unique notes to the symphony of life. But what if we could bring back the melodies that have long since faded into silence? Today we delve into the fascinating world of cloning extinct animals. From the majestic woolly mammoth that once roamed the icy landscapes of the Ice Age to the mighty Tyrannosaurus Rex, the undisputed king of the Cretaceous period. Each creature, a testament to the rich tapestry of our planet's history. But beyond the allure and majesty of these extinct animals lies a complex labyrinth of scientific, ethical, and technological challenges. Join me on a mesmerizing journey to clone extinct animals, each with a name and an era that adds a unique melody to the symphony of our planet's history. Meet the woolly mammoth, a majestic giant of the Ice Age. Imagine the frigid landscapes where these behemoths once walked, their every step shaking the earth beneath a sky painted with frost. But as we delve into the science of bringing these creatures back to life, we're left with a chilling question. Where are the well-preserved DNA samples of these colossal beings that thrived thousands of years ago? The answer lies in the very environments these creatures called home. The Ice Age was a harsh mistress, her cold breath preserving the mammoths' bodies but freezing their DNA in time. This, combined with the relentless march of time, has made it difficult for scientists to find viable DNA samples. But the challenges don't stop at the Ice Age. Fast forward to today, and the DNA preservation process is still fraught with difficulties. Modern technologies have yet to fully overcome the destructive effects of environmental factors. Sunlight, moisture, and even bacteria can degrade DNA over time, turning what was once a blueprint for life into a fragmented puzzle. And yet scientists are undeterred. They continue to explore new methods and techniques to preserve DNA, from using synthetic materials to protect samples from degradation, to developing more advanced DNA sequencing technologies. But let's not forget the mammoths. These ancient creatures are a testament to the enduring power of life, their DNA a complex tapestry woven from the threads of evolution. And while the challenge of preserving this tapestry is immense, it's a challenge that scientists are willing to face head-on. Because to bring back the woolly mammoth, to hear its trumpet echo across the tundra once more, we must first overcome the challenge of DNA preservation. And as we continue this journey, we can take comfort in knowing that every step brings us closer to unlocking the secrets of life itself. The harsh conditions of the Ice Age and subsequent environmental factors make it challenging for DNA to remain intact over time. But as we've seen, this challenge isn't insurmountable. It's just another puzzle waiting to be solved in the grand adventure of science. Now consider the mighty Tyrannosaurus Rex, the undisputed king of the Cretaceous period. This formidable beast, with its sharp, gnashing teeth and towering stature, has captivated the imaginations of many. Yet despite our fascination, the T-Rex's genetic legacy remains largely a mystery, locked within the fossilized remains it left behind. To understand why, we must first delve into the process of fossilization. When an animal dies, its remains often decompose or are eaten by scavengers. However, in rare circumstances, these remains can be buried quickly by sediment, preserving them for millions of years. Over time, these organic materials are replaced with minerals, creating a fossil, a stone copy of the original organism. However, this process is not kind to DNA. The complex, delicate structure of DNA begins to break down almost immediately after death. This degradation continues even after fossilization, with exposure to heat, moisture, and radiation causing further damage. As a result, the DNA we can extract from fossils is often fragmented and incomplete, like a book with many of its pages torn out. Piecing together these fragments into a complete sequence is no simple task. It's akin to solving a jigsaw puzzle with an unknown picture and missing pieces. Each fragment provides a glimpse into the genetic makeup of the extinct creature, but without a complete picture, it's impossible to fully recreate the original. Moreover, contamination is a significant hurdle. Over millions of years, the DNA of countless bacteria and fungi can infiltrate the fossil, further muddying the waters. Distinguishing the DNA of the extinct creature from this microbial noise requires advanced techniques and rigorous protocols. So while we've made great strides in extracting DNA from fossils, the puzzle of incomplete sequences remains. The process of fossilization and exposure to external elements lead to the degradation and fragmentation of DNA over millions of years. But don't despair. Each piece of the puzzle brings us one step closer to understanding the genetic legacy of these incredible creatures. Journeying into the ethical dimensions, envision the dodo, a symbol of extinction. Cloning, a scientific marvel, is not just about DNA and technology. It's also about the ethical considerations and the challenges it brings. When we clone an extinct species, we're not merely replicating a genetic code. We're attempting to recreate a life, a personality, an experience that was shaped by an environment, a timeline, a world that no longer exists. The dodo, for instance, was not merely a flightless bird. It was a product of its ecosystem, its interactions, its experiences. Cloning might give us a bird that looks like the dodo, but can it really capture the essence, the personality, the uniqueness of the dodo? Cloning captures the genetic blueprint but cannot replicate the unique experiences and adaptations that shaped individual organisms. As we venture further into the realm of cloning, these are the ethical dimensions we must grapple with. In the heart of technological advancement, let's explore the mysterious world of the quagga, a zebra-like creature from the 19th century. The quagga's extinction was a harsh reminder of humanity's impact on nature, and its potential revival poses a fascinating question. Can our modern technologies breathe life back into the beings we've lost? Our tale begins with a significant breakthrough in the late 20th century. In 1996, a sheep named Dolly captured global attention, becoming the first mammal successfully cloned from an adult cell. This event marked an exciting milestone in biotechnology, sparking imaginations worldwide. Could we perhaps use similar techniques to resurrect extinct species? However, while cloning domesticated animals like Dolly is an achievement, cloning extinct animals like the quagga presents a unique set of challenges. The process requires well-preserved DNA, a rare commodity considering the degradation that occurs over time. Even if we obtain viable DNA, replicating it accurately is a complex task. The slightest error could result in a creature far removed from the original. Moreover, cloning doesn't just involve creating an exact genetic replica, it also means reproducing the precise conditions that allowed the original species to thrive. This is an intricate puzzle involving everything from the animal's diet and habitat to its social structures and mating rituals. Furthermore, there's the ethical dimension. Just because we can clone an extinct species, does that mean we should? What are the potential ecological implications? Would the resurrected species be able to adapt to the modern world? Or would it merely exist as a living relic of a bygone era? These questions remind us that while we've made remarkable strides in biotechnology, we're still learning how to navigate this brave new world. As we push the boundaries of what's possible, we must also consider the profound responsibilities that come with this power. While technology has advanced, cloning complex and extinct species involves intricate challenges beyond what domesticated animals present. Reproductive compatibility introduces the tale of the baiji, a freshwater dolphin from the Yangtze River. This creature, like many extinct species, presents a unique challenge in the cloning process. How do we find suitable surrogate hosts for these ancient beings when their natural counterparts no longer exist? It's like trying to find a needle in a haystack, but the haystack is long gone. Furthermore, understanding the reproductive behaviors and requirements of extinct species is no small task. These are creatures that dance to a different tune, a tune that has since been silenced by the passage of time. To reproduce them, we must not only know their song, but sing it in perfect harmony with the rhythm of life. This is the dilemma of reproductive compatibility. The specific reproductive behaviors and requirements of extinct species create significant obstacles, demanding a deep understanding of their biology. The dream of cloning extinct animals, from the woolly mammoth to the baiji, weaves a narrative that deepens our understanding of life's complex symphony and our place within it.